Hello guys, welcome back to my YouTube channel. Today we are going to cover a physics paper. It's a Kcse prediction paper. And to make it easy for you guys, today I'm going to share two presentations. It's a paper one paper, so it have several calculations. So the first presentation will be this one on this paper. And the other one is another paper containing the calculations to make it faster. So let's get started. Now, the first question asked, state the reading on the micrometer screw gauge shown below. So this is a micrometer screw gauge, as you can see here. So being a micrometer screw gauge, we have two scales. This is the main scale here. And now this one is the thimble scale. We have two scales, the main scale and the thimble scale. The thimble scale is the one that rotates. The main scale is fixed. Now, regarding the main scale now, and the thimble scale, whenever you want to obtain a reading from a micrometer screw gauge, you have to incorporate both of them. And in this case, as you can see, the last marking on the main scale is 5. And also, before I continue, please remember that the difference between the reading on a micrometer screw gauge and that one of vernier calipers is that the vernier calipers records in centimeters, while the micrometer screw gauge uses millimeters. So now here in the main scale, you can see this is a 5, the last marking. So 5, and now if you see the point that coincides with exactly the main scale is this one here. This being 10, this 20, so this 15 is the middle point. So now you have to add the two readings. So now you have to take the reading on the main scale. The main reading on the main scale is 5, which is, you can say 5 millimeters. You plus now, sorry, plus the one on the thimble scale reading. You've seen it's 15, but now since it's on the thimble scale, it measures in hundredths. What do I mean? It will be 15 times 0.01. That's how it measures. It will be in hundreds of millimeters. This one is in millimeters, but this one is hundreds of millimeters. That's why you multiply it by 0.01 or divide it by 100 rather. So now it will be, if you add this one here, it will give you 5.15 millimeter. So that's the reading of that micrometer screw gauge. Now the second part asks, the annual drop forms a circular patch on an area 5 times 10 raised to power -3 meter squared. If the oil drop has volume of 9 times 10 raised to power -12, calculate the thickness of the oil molecule. So now for this one, let's go to the other slide. So regarding the other slide, it's the one covering several calculations on this paper. So here we are. Now, regarding the thickness of the oil molecule, we have been given that the area of the patch is 5 times 10 raised to power -3 meter squared, while the volume is 9 times 10 raised to power -12. Remember now that the oil drop is usually, you can see it's somehow cylindrical in shape. So it has an area and a height or a thickness. So now whenever you're being told to calculate the thickness is same as the height. And you have been given the volume and the area. So it's like you are generally finding the height. And as you can remember that the area, the surface area times height gives you the volume. So if you want to get the thickness, it will be the volume divided by the area of the patch, which you've done here. So thickness equals to volume divided by the area of the patch. 9 times 10 is to -12 divided by 5 times 10 is to -3. That gives you 1.8 times 10 is to -9 meters. So the thickness of the oil molecule is 1.8 times 10 is to -9 meters. Now, let's go to the next question. Yeah. Now, for the next question, uh, so this one, it asks, so name one contact force regarding the contact forces and non-contact forces. So this question wants non-contact forces. What do you mean by non-contact force? The objects involved don't touch each other. So we can talk of the one that you guys know, magnetic force. If you hold two magnets against each other, you realize that there will be an attraction or a repulsion based on the force that you are facing them on. But either way, they haven't touched each other, but you can still feel the force. And the other one is gravitational force. What is gravitational force? The force that tends to pull subject towards the center of the earth. That one is also a kind of an uncontact force. So yeah, we can talk about these ones. Now, regarding the next part of the question, a crane lifts 9940 Newton when an effort of 116 Newton is applied. Find its velocity ratio if the crane has an efficiency of 72%. So now let's go to the other slide now. Okay. Yeah, regarding the other slide for calculation. Now here we are. The efficiency. Now the efficiency of the crane, we've been given that it's supposed to be 72. Yeah, 72%. Yeah. So whenever you want to calculate efficiency, it's usually mechanical advantage over velocity ratio times 100. But now that this is given in percentage, if you take 72%, that means 72 divided by 100, which is 0.72. What does that mean? We've omitted the times 100. So in this case, the efficiency, which is 0.72 now, is the mechanical advantage over velocity ratio. But now to get the mechanical advantage, you have load over effort. Load is the one being lifted. It was 9940 Newton, but the effort being applied was 116. That's the mechanical advantage. It will give you 85.69 mechanical advantage. Now for the velocity ratio is the one that you are supposed to calculate. Now so far you have the mechanical advantage and you have the efficiency, but you don't have the velocity ratio. Now, and since the efficiency is mechanical advantage over velocity ratio, now you have to search for velocity ratio. Velocity ratio, it will be mechanical advantage over efficiency. This one here, 85.69 divided by 0.72. It will give you to 119.57. That's the velocity ratio of the crane. Now on to the next question. Yeah. Regarding the next question, a vessel, this is a calculation question. A vessel weighs 90 grams and its specific heat capacity is 420 per joule per kilogram. Now, calculate its heat capacity. Now, this is a calculation question. So we go to the other slide. Just a minute. Go to the other slide for calculation. Now, regarding the one now for specific heat capacity. Now, we know that heat capacity, which is given by a letter capital C here, is usually mass times specific heat capacity. Now you've been given that mass is 90 grams, specific heat capacity is 420. So mass, you have to convert it to same units as the one for specific heat capacity, which here we've used kilograms. So 90 grams divided by 1,000, that will give 0.09 kilograms. So now heat capacity will be given by mass times the specific heat capacity, 0.09 times 420. That's give you to the 7.8 joules per kilogram. No, not per kilograms. That means that 8.7 joules. Now we go to the next part of the question. The next part of the paper. So here we are. Explain why a jumper flexes his knees when landing on the ground. Why does a jumper flex his knees when landing on the ground? Remember, these jumpers, be it even in those ones that do the pole vaults, yeah, you have to make sure that you spread your legs or flex your knees when landing on the ground. What does that mean? To flex your knee, it means that you will have to increase the time of impact with the ground. If you flex your knee, that means that you are reducing the angle, between the thigh and the leg. That's what we mean by flexing your knee. So whenever you do that, is because it means that you will be increasing the time of contact between yourself and the ground. And as you can remember that impulse, write it here, impulse equals force times time, yeah? So that's impulse, the impact that you'll feel when hitting the ground. Now, being that impulse is force times time, if you increase the time, you reduce the force. You see, if you increase the time here, let me demonstrate. If you increase the time, you'll be reducing the force of impact. So generally, whatever they do is that they flex their knees when landing on the ground to increase the time of impact. But now, when they increase the time, they'll be reducing the force of impact. So they won't feel much impact and there will be less damage. Yeah, that's why they usually flex their knees when landing on the ground. Now, on to the next part of the question. Two tennis balls are suspended from support by a thin string and air blown between them. Explain the consequent motion of the balls. So you may now try even this at home, yeah? And you see that it's true. If you suspend two balls from the air, and okay, from a support by a thin string, okay, don't put a much distance between them, just a short distance between them, and then you blow air in between, you realize that the two tennis balls will tend to come closer to each other, as if they want to touch each other, or even touch each other. They'll come into contact or closer to each other. Why? This is because now, okay, let me just type it. Explain the consequent motion of the balls. So the balls come closer to each other. Why? This is because when air is blown, it's blown in between the speed of the air, speed of the air, the speed of the air between the balls increases. Speed of the air between the balls increases. And now when the speed of the air between the balls increases, the pressure between the balls, on the other hand, the pressure between decreases now. When the pressure decreases, the outward pressure pushes the two balls towards each other. Towards each other. So that's about it for the reason as to why the balls come closer to each other. Now let's go to the next question. Give a reason why heat transfer by radiation is faster than heat transfer by conduction. So this is okay. I won't have to type this one. It's very easy because the reason between why the heat transfer by radiation is faster than heat transfer by conduction is because now radiation uses electromagnetic waves. And doesn't require any media. It can move even through vacuum. But now for the conduction, on the other hand, conduction uses what? Vibration of particles. So obviously, as you can expect, you can't expect the same speed of the waves to be same as the speed of the vibration of the particles. So that's why air transfer by radiation is usually faster. And also remember conduction requires some media for it to be propagated. Now the figure below shows a fire alarm circuit. Explain how the alarm works. Now if this is a fire alarm circuit, now guys, let me show you a trick here. If you want to determine how it works, you may not even know the expansivities of Browns and ion, but they're the one that will trigger this alarm. So you will always have to check during your exams to know how it will work. As you can see right now, the circuit is incomplete. Why? The contact point doesn't have a contact with the brass and ion. Yeah? So means that in this state, the alarm is not triggered. But now imagine the case of a fire. You'll want this one to come here so that it can trigger the alarm. So what happens? Obviously, we expect now brass. Okay, remember these are two metals. So you'll expect that brass will expand at a faster rate than iron. So when it expands at a faster rate than iron, it will always increase more in size. And when it increases more in size, it means that this metal will curve towards this way. Let me draw it the way it will curve here. So it will curve like this. We expect it to curve like this, maybe something of the sort. You know why? Because this brass has expanded more than iron. So when brass expands more than iron, it will curve inwards. When it curves inwards, it will establish a contact here. When it establishes a contact, there will be a triggering of a fire alarm. So that's how we explain how it works. Say brass expands more at a faster rate than iron. It will then curve. When it curves inwards, it will establish a contact, completing the circuit, triggering the fire alarm. Now on to the next part of the paper. It's a calculation question, so we'll probably have to go back to our slide, but let's read it first. So two liquids of density 1100 kilogram per meters cubic or per cubic meter and 850 kilograms per cubic meter are mixed in equal volumes. So the mixture fills the tank of 300 centimeter times 40 centimeter times 50 centimeter to the brim. Okay, this is not to the brim, it's the brim to the top. Calculate the mass of each liquid. So you can see here, there are two liquids, each of different densities, but they are mixed in equal volumes. So meaning that this volume which fills the tank has been contributed halfly by this one and halfly by this liquid here. So when you want to calculate volume of each liquid, you obviously have to get the volume of the total, make it to be the same units as this one. And then after that, you'll have to divide it by 2. Why? Because the volumes contributed equally from the two liquids. Now, the mixture fills the tank of this volume. Calculate the mass of each liquid. Now, if you have the volumes of each liquid, then calculating the mass will be easy. Why? Because mass will be volume times density. Let's go to our calculation paper and see that. So regarding this part, here you have this question. Yeah. So now density of the liquid 2. Sorry. So you have the density of liquid. Liquid 2 is 850 kilograms per meters cubic. Now let's calculate, we want to get the volume of each. So let's calculate but we'll use just one liquid because if you use one, we'll get the other one. Density of liquid 2 is this one. Dimensions of the tank is this one. So let's first calculate the total volume of the tank. So we have to change this to be meters. 0.3 meter times 0.4 meters or 0.5 meters. It will give you 0.06 meters cubed or cubic meters. So that's the total volume in the tank. And this volume has been contributed to by two liquids equally. So that will be, to get the volume of each liquid, we'll divide by 2. 0.06 divided by 2. That will give you to 0.03 meters cubed. And then for the mass of each liquid, mass will be density times volume. Now for the density times volume, that's 11 for the liquid one. It had a density of 1100. So 1100 times 0.03. That's 1100 is the density times volume 0.03. That's give you to that 3 kilogram. That's for liquid 1. For liquid 2, The same thing, density times volume, 85 times 0.03, 25.5 kilograms. So mass of liquid 1 is 33, mass of liquid 2 is 25.5. It's simple. Now we go to the next question. Okay. Regarding our next question here. Now here we are. Give a reason. Oh, sorry. You are here at number 10, so you're supposed to move to number 11. So in a Brownian motion experiment, this one here, smoke particles are observed to move randomly. Explain how this motion is caused. Now in Brownian motion, there's something called a random bombardment, right here. Write it here. Random bombardment by air particles. So in this case now, in Brownian motion, it's whereby we have a smoke cell. You put smoke inside, and then now if you illuminate under a microscope, you will be, okay, or under a lens, you will be able to see that there will be some random white sparks moving randomly. Now, it is in the case that you have a source of light, and then you observe under a microscope. You'll see that there will be a random movement of white sparks. Why is this? It's because now smoke particles will be, when illuminated with light, they'll kind of absorb that light and appear as white sparks now. And now the reason for their movement is because, remember, when you put smoke, initially there was air particles. So the air particles are in a continuous random motion, which is the Brownian motion. It's a theory which has been proven to be true. So these air particles will be hitting the smoke particles. The smoke particles will then move in random motions. Why do you smoke? It's because when you smoke, okay, you want to establish the movement of air, but well, air is somehow invisible. That's why you use smoke for visibility, to establish that matter is usually in a state of motion. That's the Brownian motion. And now for the next part, give a reason why the weight of the body vary from a place to place on the Earth's surface. Okay, well, this is not usually so much common, but it may happen. Remember that the gravity on Earth is usually estimated to be around 10, but it's usually around 9.9 or something. But well, this gravity is not exactly same in every part of the Earth. So it means that in some places, you'll get that this gravity is less compared to others. So the reason why the weight of a body may vary from one place to another on the Earth's surface is because there are slight differences, very slight differences in terms of gravity on the Earth's surface. That's why you get some difference between them, the weights of the body, of the same body. Now, the pressure in a moving fluid varies with the speed of the fluid. Explain. The pressure in a moving fluid varies with the speed of the fluid. Explain. Now, if you consider this, we've also covered a similar question up there. The one of the balls, suspended balls. It is usually established that whenever you have a fluid, and well, the fluid, it has two properties. You can talk of pressure and speed. Whenever you increase the speed of a fluid, you'll always observe them that the pressure decreases. And whenever you decrease the speed of the fluid, then the pressure increases. So it's usually a vice versa. Why? Is because the energy is because of energy. Energy, let me talk of energy. So energy is constant between is in between the fluid is constant. What varies now is the pressure and speed of the fluid and speed which varies. So energy is constant, pressure and speed varies. So whenever the pressure increases, there will be a decrease in speed. Whenever the pressure decreases, it means there's an increase in speed. So that's basically about it. So guys, we are done with section 1. We won't cover the 2 sections today. So we're done with section 1. Kindly let me know if you have any questions in the comment section or any places that you wish we may clarify. And also, please guys, kindly remember to subscribe to my YouTube channel so that you may be informed of more upcoming videos. Yeah, so you guys, you have a nice day.